Yes. Okay. So please tell me what you remember about accuracy and what you remember about precision.
All right. So with the accuracy now, sir, accuracy is how close you get to the value.
What value?
What value?
Mm-hmm.
Depending on what you're trying to find. So depending on
There's
how
a
close
word that we use when there's a reference word that we use when we say accuracy. So it's really a comparison between a standard and what you're measuring. So what do we say? It's a comparison between what you measure and the standard, the true value.
the real
That word,
value.
true value, right? And then what the precision is now.
Precision now would be like basically identical to the real value.
So precision mean that yes, they are in more of a clustered in the same range, right?
Yes.
But the meaning that they are still not on the bullseye, but they are. It in other words, it fluctuates around the correct value. So if it's a correct value, it fluctuates around the correct value, but it's still not dead center correct value. But so they are close. They're in a cluster. The measurements are in a cluster. They are close. So if you're measuring 8, I suppose you get 7.99. And if you get 8.11 and the figures are clustering around 8, then you know that it's close to precision, right? But you're not getting 8. Yeah, for argument's sake. All right. So that's how we look at it. Then you of course you have the diagrams that you can use and show the different precision. And you have one you can show accuracy. And you can also draw the contrast between accuracy and precision and show the difference between them. Right? All right. So if you're given a problem like this one, all right, the first part, you should at least know how to do the first part. Right? The second part might be a little challenging, right? And the latter parts. But let's look at it. Let's look at it. The first part. So we get part C. All right. So it is in about 4 parts. You have question. It says A part, B part, and C part. The C part says what there now? All right. It says
then V1.
Right. It says. Let me see if I get my writer. My writer will write for me. Oh, where am I? It's not writing. Oh, tell you what. Oh, it's not writing. I don't think I have a pen. My pen should work here now. I haven't used it in a little while over here. Oh, beautiful. It's working, man. All right. So wonderful. All right. So C. So part C now, we're right here. All right. So it says V1 is minus 5i plus 7j. So we know what is V1. It's minus 5i plus 7j. And V2 is what now? V2 is 2i minus 3j. All right. If it says to you for part 1, you are to find the magnitude. What would you do with V1 plus V2? What are you going to be doing? So it's here to find V1 plus V2. Right?
You're going to substitute, sir, and solve.
Substitute? So, all right. So it means, how am I going to substitute? I'm just going to put this here and that here and get them. So it's like, I'm going to just put 5i plus 7j.
Plus 7j plus.
Plus, is that the right way to do it? Is that the right way to do it? If it's the right way. And then what you do after that? If you do that, what else you're going to do?
We're going to have minus 3i.
Minus 3i where?
Just equal minus 3i, and then you have
man, you can't do it so. You have to do it in order so that at least we can know what you're doing. Now you reach answer, you don't tell us how to do it yet. You know, oh, you jump in the gun, so man. All right. So the first thing you need to do, you need to look where all the common, the I, you group them. So you get minus 5i.
But sir, if you do it in alphabetical, so?
There's 2i. You do it in sequence, man. Right? You get that, you have those two. And the next one you'll be doing now, you're doing 7J.
Minus.
Oh, that don't look like a 7. That looks like. I don't know what it looks
A
like.
capital J.
All right, let me get 7 there. Right. And then you will get what else you have? A minus 3J.
Minus 3J.
All right, so this
Yes,
one
you have
works out
minus
to
3 here,
minus
so
3I.
3I, and then you have
And then you
plus
work out this part, now you're
4J.
gonna get 4J. So you didn't see that. You see, I thought you were finished there when you tell me 3I.
No, sir, you never met me finish.
Okay, right. But I want you to show this. You have to show you're working, right? Always. And showing you're working, it will help you that if you're going wrong, you can have something to look and say, oh, but I'm going wrong there. I've left out something, right? So you must always show working. You'll get more marks of working than just do it in your head. We want to see that you understand, you know, and you just didn't guess the thing, right? So that's why you need to show all working. The next part says the direction of V1 plus V2. Now, how would I get the direction of V1? So it says you will determine the direction. So remember now, if this is a 2D frame, one way to do it is always
So
go
I
to
go
a
show
diagram.
say it flip.
So, all right, so if you have it in a frame like this, you can have what? Minus 3i. If minus 3i would be coming, if this is a 0 point, then you could say your minus 3i come that way, not true? Right? And where is your 4J going to go? And your 4J. So if you remember that is a positive J, this is a negative J, this is a negative I, and this is positive I, not true? So if you're going to go now 4, you're going to go this direction. So it's going to be 4 here, right? And from that, you can find your direction, not true? Because, right, you can find your direction now. So in terms of where you're coming from down here, this is the angle attitude making, right? So give you your direction, right? So you can say, what direction am I going? Or is it, right? So you look at the direction. So it's not actually this one, it's really this one down here. So it's really showing you, this is where the resultant is. So that's the direction angle. So it's coming from the 0 point, which is down here.
Sir.
Here, yes?
So
let me
when
draw that down here
ask,
again. Let me draw it down here for clarity. So this is 0. You go minus.
I have a question, sir.
Yeah, I'm coming. Let me just draw it for clarity. And then you come up here where it's 4, right? Right. And then, so that is more acting like the resultant, eh? That is it. If you took that shorter route, then you'll reach here, right? But you have to know what angle to go there by. So it asks you for your direction. Well, ask a question now, man.
So when them ask you for like what's the direction, you're going to draw a diagram?
Not necessarily. But in this one, is a 2D frame, it is easy. If it's a 3D frame, you have to go to your calculus and not necessarily calculus, but you have to go to your polar coordinates. You have to reason it out from a polar sense. So from this, you could one thing you know V1 plus V2 give you what? That's the first thing you need to know. But at the same time, so that means if you want to find out your resultant across here, you could find out because you could use Pythag theorem to do it. If you use Pythag to find out your R, in other words, so your R would have been what? Minus 3 I square, all of that square plus 4J square. You ignore the I and the J, they are going to be, you consider them as 1, eh? So they're really, but I just put them there for symbolize, not to really work out there. Just symbolizing that everything is square. All right, and you take the root of that because remember, so this was square, Pythag. And so that will give you 9 plus 16. So that is gonna give you what? Now 5. So you know, so this is actually 5, and that is, you know that this is a 4, 3, 5 triangle. All right. Only that one side is going to the negative. Now, knowing this, so you find R. That is the resultant. But that's not what they ask you for. They ask you for this angle here. Or you find that angle here using your trig ratio. You could use your tan. Tan is what? Is opposite upon adjacent. So the opposite side was 4 upon 3, you know, so? And therefore the tan inverse of this angle is going to be 4 upon 3, which is what, 1 point something, 1.33 inverse. Can you find that angle for me, please?
Hold on, sir.
Who is that other person join the class? And I want to hear from the rest of guys. I thought I saw Kenrick. Mr. Arson.
Yeah, I'm there.
I don't want you to be a stranger, you know, sir. I want you to talk and let me know that you are here, sir.
Sir, background always noisy. That may I try to protect the class from.
Okay, all right. When you're talking, you just open the mic and signal and speak and then close back. All right? Fair enough?
Yes, ma'am.
All right, good.
So hold on.
Yes.
Sorry, yes, if you find tan inverse of 4 over 3?
It's 4.3, yes. 4.3, what would I get? About 1.33 something if you have to divide 4 by 3. How much you get?
Sure, what you said? You said tan inverse.
Is 1.33, now so? So the tan inverse of that of 1.33, what do you get?
1.33, hold on.
You don't know how to do that? You go shift.
Oh, sir. Hold on, sir. 53 degrees are 53.
Yeah, what do you get for that angle?
53.
53, not 53 flat. Give me some decimal point. You're just doing, you're doing.
All right, 53.13.
All right. So if I tell you, I want it to what? 4 significant figure, how much you would give me?
Huh?
If I said to you, give me 4 significant figure, how much would you give me?
4 significant figure?
Mm-hmm.
Which is 53.13.
Isn't that what you get? 53.06?
No,
That's
sir.
Your calculator give you a different from mine? Apparently your calculator give you different from mine. So, all right, fine. But that is 4 sig, which is what? 2 decimal place. Right? All right. Now, so that's your direction. In this case, they ask you for the direction of V1 plus V2. So you see the direction there? So it is, and you know R is what? So R, the resultant is 5. They never necessarily ask for 5. Well, they ask for the magnitude up here. So the question never really finished. Once they ask you for the magnitude here, class, you need to use the Pythagoras and find the magnitude. This was just symbolizing it, but you need to finish it up. We're getting the magnitude in, all right, this is the magnitude, but it is in Cartesian format. To get the modulus answer, the 5, you have to use the Pythagoras to get the numerical value, which you know you could use. Could you break this down into unit vectors? By the way, class, based on what I told you about unit vector, let me copy all of this and carry it around because I want more space to write. I had it before, but I'm going to, let me see if I use my pick tool and carry it around. I want all of this, and I'm going to go into OneNote. Tell me, all right, I have something there. Let's let that stay there for the time being. Come on. All right, beautiful. So that is OneNote. All right, when I'm moving across there. All right, so this is OneNote. OneNote kind of make the thing a little bit. All right. What is going on here? Why do I have so much section here? Why do I have so much section here tonight, Jesus? I want to get rid of one of them. No, I don't want to have anything here. Why am I getting? Hold on. All right, this is what I want. Come on. All right, let's see if this can work. I'm giving more space. All right. So what I'm simply saying here, class, your magnitude, right, you find in the part 2, this part here, right, you actually got it to be V1 plus V2 was really equals in modulus form of it, where you have it, it is in the unit vector form, right? So, but if you want to find the actual, what do you call now, the scalar value of it, the scalar value is really 5, right? So, but you'd have to use Pythagoras. That's all I'm saying there.
Who
All
will
right.
get 5, sir?
Hello? Someone saying something?
Yes, sir. How you get the 5?
Remember we use Pythagoras right here? See it right here? Are you see my stylus? Right here. We use Pythagoras. You forget? You use Pythagoras of this. You do the Pythagoras of this. In other words, you find the modulus of this. What will be the modulus of this? Because remember it will be 9 square plus 4 square, right? I mean, this will be 9, pardon me. This will be what? Let me go again. This will be 9 plus 16. There's a root
Minus,
of that, which
minus
is
9.
which is it's not minus 9, ma'am. Where you get minus 9 from?
Oh, this
It's square, you know. If you get
yeah.
minus 3 times minus 3 is 9. Right, so you
Mhm.
can't say minus 9, ma'am. You couldn't say that. All right, next one. It says here, the next part now, it says the direction of the angles. And we found that. We show you that you just draw it using your notes. So all you know what it is what? Minus, when you add them, you get minus 3i plus 4i. So it goes in the negative zone, right? Negative 3, and it goes positive 4 up in the positive y direction. So that you do, and it's coming from this direction. And this was where you start from. So this must be the angle that you need to find. So, right, so you see your resultant there. So you go that way and you go that way. So the shorter route would be across here, which is a resultant. Which you know, so that is 5. So you can use it any which way you want to. Any other, knowing 5, you could also use the sign and the cos. Right?
So,
But
sir.
you don't need to do that. You just use the tan. Shortcut. You don't need to find the R. So it is actually correct if you just leave it in minus 3, 4i, you know. But you could actually go ahead and find the scalar value of it if you want to carry it further. If you want to take it out of Cartesian format. Because presently using Cartesian format, right?
I have a question, sir. So basically, you're saying that the magnitude and the resultant is the same value, or is the same thing?
The magnitude and the resultant in this case, yes, it's the same thing there. But depends. You can't. You have to put it in context of what you're looking at. Right?
Yeah,
so
I understand that, sir.
And the two of them were in Cartesian format. The question says to you, what is the magnitude of V1 plus V2? You found them in Cartesian format, but you could also find them from once you find them in Cartesian format, you can go ahead also and find the modulus value. The modulus value is a resultant of it.
Yes, sir. I understand that, but I'm asking all like in every case, it's the same value.
In every case, the same value. No. So if it's 3 of them, you use the same Pythagoras. If it's 2, you use Pythagoras. Whatever value you get. In this case, it happens that it is a 4-3-5 triangle. So
sir, you're not listening to the question I'm asking, sir. I know that for each question, it will have well, if for like number 1, it asks me to find the magnitude and I get 5. Say for example, question 50 then asks me to find the what you call that, resultant, the resultant. Yes, would it be the same value? It's the same question, you know, same value and everything. Would it be the same 5?
I'm not sure if I follow you. I have to make sure that I
Sir,
understand.
just like how you find the magnitude here, which is 5, and then you go down there and you say the resultant is also 5. I'm asking you, say a different question. Would the magnitude and the resultant be the same value?
The magnitude and the resultant. Yes. Depends. Yes. Yes.
So that means I say, yes. Say everything now go really be 5, but the same value.
Right. So in other words, yes. So when I say in this case, what and as I said, you know, you have to be careful not to confuse yourself because you have to put everything in context. You can have the magnitude or the resultant of a vector written in many forms. It can be written in what you call polar form, where it's written in terms of angle, and it can be written in Cartesian format. right? And it can be also written in unit vector format. The unit vector format is still what? Cartesian format. So you have to be careful not to mix them up. But you're gonna get more question, if not in this course, in static. So it will clarify it. So don't worry, we will clarify it. And by the time we finish, you'll pretty much understand where we are. Hopefully we get a chance to work one or two more questions. All right, but in static for sure, we do much more. And in fact, you'll understand what we do in a little bit. It's quite a little bit of vector we do in both courses. All right. All right, this other part now, it says here, so we're transitioning now. The position, D now, they want the position of the particle as a function of time. So the position of the particle as a function of time is given by the expression R is 4t plus, wow, what did I do? Something went wrong. What did I touch a while ago? I think my hand accidentally touched my mouse. Cancel. What is happening here? You know, something just, well, let me see if I find it back. All right, we're back. All right, so it says here, are you seeing what I'm seeing about the page? Are you seeing it? Hello? Guys, are you still with me?
Yes, sir. Yes, sir.
Oh, okay. Because momentarily my hand hit my mouse and everything. All right, so we are saying here, remember the background that you have there, please. So you have 4t plus 2t square is equal to the I, plus 5 minus 2t cube is a j, where r is in meter and t is in second. All right. So this, of course, is showing you that your displacement, the particle as a function given by this, and your displacement is in the form of t. And it represents, a section of it is representing I for the x component, and this part here 5t cube j for the y component, where r is in meters and t is in second. All right, so that's your displacement. As you see that, and you see r, you know, so that's your displacement expression. So it says the position of a particle as that. So it has some displacement, and that is the expression that shows your displacement in terms of t. It says determine the displacement of the particle between 1 second and 2 seconds. Fair enough? You good to go with that? You understand what is happening right there? So they want your displacement, right? So firstly, your displacement, and I trust that my dogs don't really make noise that you can't understand here. So the displacement of the particle at t equals 1, that is easy. All you're going to do at t equals 1, you're going to put r equals to 4, and you're going to write back the expression, and you know the expression is this, t plus t square, right, and that is the I, plus the other part would have been 5 minus 2t cube, and all of this is what? The j. All right, so wherever you see t, you're going to put 1. So it's 4 times 1 plus 2 times 1 square. All of that is what? Is I, plus 5 minus 2 times 1 cube. And all of this is equals to your j. Let's see what I work out to. For the first one.
Sir, before you move on, where you get the I, the time to be 1 down in the displacement of the particle between. Okay.
It was given. Okay. See the question there? See it right here and see t equals 2. So it's t equals 1 is where I'm working with from. All right. So for this first part, it is 4 times 1 is 4, no so? Plus 1 square is 1 times 2 is 2. So that is equals to 6i. Not true? Plus this one is going to be what now? 5 minus 2 times 1. 1 cube is 1. Times 2 is 2. Right? And all of that is equals to beautiful J. So therefore, it is 6I plus 3J. Right. So that is the answer. And that is what? That is for which one? That is for T equals 1. What about T equals 2? Let's go up a little bit more. T equals 2. So it is T equals 2. Put it back in this expression here. That guy up there. So it is 4. So R is equals to 4 times 2, right? Plus 2 times 2 square, that is I, plus 5 minus 2, 2 cube equals to J. All right, so what else do we have here now? So it is, this is 8 plus 2 2 is 4, 4 2 is 8.
16I.
Plus, this one now is going to be 5 minus, all right, 2 to the third power, that's 8, times 2 is 16. Agree? Who don't agree?
Sir.
Everybody agree?
Yes, sir, yes.
All right, so therefore, the first one is 16I
Next
plus,
one, a minus 11.
oh, yes, there is a, let's get a
Minus.
eraser here. I don't want this thing right here. All right, where's my writer now? So it becomes minus 11J.
Okay.
So that is the, when it is at T1 and T2, not true? All right, so that you have the expression when it is at T1, what's the displacement at T1 and T2. All right, so you could call this probably R1 displacement is 6.6I plus 3J. R2 is equals to 16I minus 11J, right? You can probably symbolize in that way. All right, this next one, it says, determine the particle's instantaneous velocity at T equals 2 seconds. All right, I'm gonna rewrite the expression. Let me rewrite it bold. All right, tell you what I'm going to do. Hold on a second. Let's crop it. We want to have this nice little part here. So we have it somewhere down here. So we always have it very present with us. Very present with us. All right. So we won't miss it a bit. All right. Now, so now that we have our displacements, we have R1 and R2. All right, and remember what they are. All right, see them right here. So, right. So let me just put R1 right here. So this is R1, and this is R2. All right, if you miss them up top, you'll see it here. All right. Now it says here the term, the particle instantaneous. When they say the word instantaneous velocity, can somebody tell me what are they saying to you? Explain the word instantaneous to me.
At a particular time.
All right. At a particular, well, but it's at a particular time, but it means that it's a moment it's like an instantaneous, is like a sudden, more, it's like at a particular point, you know, momentarily where it was at that point. It means it stayed there, but it's at that instant in time, it is right there, right? At that particular time period, it is right there. So it says you must determine your velocity right there, so, right? When it's at that particular time. Now, can somebody tell me how we approach this one here? Can somebody explain to me in real terms? How do you approach it? Given your displacement, what did I tell you about your displacement? Anybody remember anything about displacement? And how you, and this is calculus, of course. And you all say that you're not too hot with the calculus. But nonetheless, you have to be hot this part here, right? The course don't have a lot of calculus, but this part is calculus. we still have calculus in the next topic, which is simple harmonic motion. So yeah, it's a little bit of calculus is here and there, and I'm probably going to start to feed in more calculus in some aspect of it, right? Because you need to get used to it. When you go up to UTech, you have to make sure that you can manage and manage it well. When Dr. Brown, well, I don't know if Dr. Brown still teach up there. When Dr. Noel Brown get you into his class, what they're going to be doing thermo D, or eat elements and whatever. And I'm really touching some of those courses in this physics here. But he will take them into a different dimension, special electives. All right, come on now. Let's move it.
Sir, you're not going to substitute T for 3?
T for 3? What are that it asks you for me, dear? What is it that it's saying? It is saying to you that when you have displacement, you remember we had a discussion. All right, let us stop here for a minute. We're going to go revise for your benefit. Let us go revise. If I do this, do you see anything?
So I know that displacement is a vector and it has direction.
All right, let me run on to something here. We want to do a little review, right? And we're going back to look at our displacement expression. Where is it? All right, so we're at displacement. Come on. All right. So can you see where I'm at now? I have to stop. Let me go again.
You never be stopping on my seat.
Yes, right. Oh, hold on. If I do this, you're not going to see anything when I shift. Let me do it again. I want to have everything there, so when I switch one place, you see everything. All right. So you remember, when you have instantaneous velocity, in order to get instantaneous velocity, you must differentiate the distance in respect to time. So that's how you go dv upon dt, and it doesn't matter whether or not it is in Cartesian format, the rule applies just the same, eh? You see it? And this is where you are. It's quite want you have instantaneous velocity. I'm not talking about the average right now, right? We can always find the average, but it never answers for that, right? The answers are the instantaneous, right? Hold on a second. My laptop is not plugged in. Hang on. It's a good thing I can see. I'd have lost the class immediately. All right. So, all right. So now, what it means is that we need to do some differentiation of the distance. When you differentiate the distance in respect to time, you will get velocity. And that's exactly what we're going to do. So we're taking, this is what we're approaching to do right here. So, and we get the Vx, Vy. If it is 3 components we have, we get this. If it's 2, we get the 2 first one. All right, so let's switch back. I'll go back to here. All right, now, so we are going to differentiate our distance. So we are going to do, in order to get our velocity, it's going to be dr upon dt, right? Right? So we're going to differentiate our distance. So we're going to get d upon dt of this big guy here, 4t plus 2t squared I plus 5 minus 2t cubed j. That is what we're doing here. So let us proceed. So our velocity now is, we're going to differentiate each one of the quantity. Can take them down slowly. I will keep the I big. All right, let's just do what is inside first for the I. All right. Okay, so the first one, 4t. Remember, it's going to be, it is to the power of 1, eh? So it's 1 minus 1 times 1, right? That is the first part. All right, we look at what leaves left there. Plus, let's do the next part. The power to the t is 2 up there. 2t squared. So it's going to be minus 1 times 2. All right, that is the first part. Plus the last part now, when you differentiate a constant, what happened to a constant? A constant is t to the 0. That's all. Right? That's really what it is really saying in essence. Right? There's no, so it's this come to 0. All right. And then you have minus 2 times 3. Let's erase that for clarity. Look untidy. So you have the 3 here. That look untidy also. Let's go again. All right. So that's 3 times t to the 3 minus 1. All right. So you multiply by whatever the power of the algebra is. You multiply by the power, subtract 1 from the index. So you multiply by the power of the index, subtract 1 from the power of the index, and that is differentiation. All right, but this is to the what? To the j. So therefore, this one will give you 1 from 1 is 0. So it's t to the 0, which is what? 1. So that is 4. Come on, what is happening here now? Come on, that tool gone buzzard. Escape. Gone escape. Something else. Oh. Uh-oh. What is my keyboard control? Escape. Okay. Oh, I wish I could get rid of all of that.
Sir, what did I do?
Oh,
Just undo it now.
I'm trying that. My writer went buzzard. You know, it's one of those things when you're doing a writer and the writer does. All right, so it goes. So that is 4. 4. This become 4 because t1 minus 1 is 0. So it's t to the 0, which is 1. All right, so that becomes just 4. 1 times 4 is 4. Plus, this part now gonna become what now? 2 2 is 4. And 1 from 2 is 1. So it's t to the, it's just t. And all of this is give you what? That is I. All right, plus, this is a plus sign. And the next part, this is 3 times 2 is minus 6. All right, minus 6. And this is what the t now. What's the power of the t? 2. 1 from 3 is 2. But all of this is to the what? No, J? All right. So let's get that up. So what this really work out to be is 4 plus 4t I minus 6t squared. Yeah. All right. So that's what that really is. Okay. And that's your velocity. But did they say something to you? What did they say? Determine the instantaneous velocity at when t equals what? Says when?
So you never put the 2 in
Equal
it.
to.
Oh, right. So therefore, your actual velocity now is going to be 4 plus 4
8.
2 I. Be careful. You know. Be careful. Be careful. All right. All right. You have a problem.
12
Yeah, well, is it 8? Is it 8? Look good. Is it 8? It's 12. It's what? 12. 12 I.
Yeah, man. But no, when you
Minus
write it, you
6.
think you just write 8.
No, man, I have to make sure I go everything in stages. Make sure that
That
me not drop the gun. That's why I didn't call. I have to, you know. Yeah,
man.
right. So this is 12. I don't want to drop the gun at the end of the day when I say, boy, this man just all right the thing. So all right. So this is 20, what, 24? Am I correct there?
2 2 is 4, 6 4 is 24. Yeah.
All right, good. Right. All right.
Negative.
Very many slips sometime between the cup and the lip. So we ensure that we calibrate the brain. Make sure the brain is
Yeah.
functioning right. So that is 12I minus 24J. And that is what is your what? That is what is your velocity. Then if I ever said to you now, Miss what's his name? Is Anika? So Anika.
Sharp. Yes,
What?
sir.
So if I say that to you now, if I say to you, Anika, that I want the scalar value of the velocity, how do you find that? Can you put a question around here? So now that I was wondering if I could answer you correctly, I don't want to mislead you. So therefore, I am using this opportunity to see if I can clear up that. If I said to you, I want the scalar value of your velocity, which is going to be what now? Meters per second. How do you get that from that value there? Even that
Sorry, I squared 12
in Cartesian form.
Huh?
Pardon me?
Sorry, I got square the 12, right?
Yes.
Minus, and you have square 24.
So, hold on, let me write down what you're saying. So you're going to square the 12, and then what else you're going to do?
Minus.
Minus. Where you get
Plus.
minus from? When you find a modulus, where minus come from in a modulus? So all right. Argument 6 minus 24 square. Yeah. And then what else you do?
Yeah, I'll go find the square for them. Hold on. That will be 144. And then 24 square. That's going to be positive. So it's going to be 576 plus 144. 720, and find the square root of 720, which are going to be 26.
Root. And I root you want.
Yeah.
That you mix me up.
Yeah, that's it.
About square, me I say square of that. Is a root you want?
Sure, that's what I meant. Yes.
Yes. Make sure you say the right thing, because you know you have to be very.
I have a problem with that, sir. I can write.
Yeah,
you know what me I say?
Right, but guess what? Say the root. Because the root, when you find the root, remember the root is supposed to help you that when you multiply it by the root, it gives you back the square. You understand me?
Yes, sir. Yes.
So it's the root of it. The root. So it's the square root. Or you could find the cube root. So it's the root you want, the root. That means that term that when multiplied by itself, whether by square or by cube, if it's 3 times, they give you back the actual value. So remember, try and use that word root. All right, so yes, that is how it would have been done. All right, so what is the actual value? You want to give it to us?
Sir, I think, hold on. 4.
So it's 144 plus 576 root. And
so that will be 720.
Scalar value of that
26.
quantity. What?
26.83.
26.83.
3.
That is what? 4 signal figure, 2 decimal place. Argument sake. And it is, that is what? Meters per second. All right.
Yep.
Because velocity, remember? It's velocity. All right. I remember R was in meter, time was in second. All right. So we have that so far. And then it goes on and it says to us, determine the particle instantaneous acceleration when time equals to 3. Now, who in the class now want to take it on away from Anika? Who want to take on that part?
Sir,
which part, sir?
Pardon me? The formula? The formula
is instantaneous acceleration.
Yeah, man. You see the formula here? We don't want to get lost enough. Let me just scrap the formula alone, carry them down with us so we have space so it not lost. I mean, what me carry everything. Not too much.
And I formula that, sir. I formula that question.
No, we just going to drop this right here. So we just want to make sure that, and you see this little gap here, we're going to just put him up there. All right. So we are saying we want to find the particle instantaneous acceleration when we have that distance there. So this wonderful distance here that we know is R, and it is 4t plus 2t square I plus 5 minus 2t cube. And this is what? J. Or what is the velocity though? Our velocity really now, the velocity expression is really equals to what? 4 plus 4t. Not sure. What was the last part? Minus something. Minus what? 6 T squared J. All right. That's
Sir, why you have to write that day? Why you never write back the final something where they get?
No, because that is a car. No, hold on. This is when you put in 2 in it.
That's
you need an expression with T. You can't find it without an expression in T. This is only giving you the numerical. This is giving you the velocity when T equals 2 with the Cartesian component, right? You understand what I'm saying? This right here. Can you see my stylus? Can you see it?
Yes, sir.
Right. You see here? This is only giving you the answer. Whoa, let me see if I back up. I think I touched something there and it kind of, yeah. I don't want it corroded. Yeah. So you see it here? This is the answer. When T equals to 2. It don't have any T in it. So you have to go back here, so. This part is where we find is a fundamental part right here, so. Because why is that part the fundamental part? That is the velocity expression. After knowing the distance, and when you differentiate, you get a velocity expression, which is this guy down here. Right? So this is what you're going to work with now. And it is out, and why? Because it have T in the expression. And it is saying it is velocity. So now when you differentiate velocity, what do you get? You get acceleration. If you differentiate displacement twice, you get acceleration. So now you have velocity. So you are going to differentiate the velocity to get the what? The acceleration. So you must have an expression which says that the velocity is some quantity in T to give it to you. You understand what I'm saying? So now all you're going to do right here now, and remember now, they give you at the instantaneous acceleration is when T equals to 3 seconds. All right, good. All you're going to do for me now is that we are going to differentiate the velocity expression in respect to what? T. All right. So let's go. So what we need to write here is say that the acceleration now is with d upon dt in respect to the v. What is the v? This is a v. So in other words, let me rewrite it again. So for clarity. So this is what we're finding. Come on, where's my expression here? All right. Come on. Eraser is giving me a little problem here. All right, that gone. Good. So now it says that that is what we were trying to find. So it therefore means that for your differential function, you'll need to put this right here now, because this is your v. 4 plus 4t I minus 6t squared j. And that is now your, so now we're going to differentiate. So the first term, when you differentiate 4, you get 0. When you differentiate 4t, what are we getting? The t here would go, and you only left what? With 4. So you get 4i right there. So I'm doing it now without giving the workout, because you should understand it now. With this one now, when the power is up here, you reduce the power by 1 and you multiply by the expression. So it becomes minus 2 times 6t, because it's reduced by 1. Eh? And this is what? J. So therefore, your expression in acceleration now is 4i minus 12t j. Do you follow? Who don't follow? Who don't follow now? Who don't follow?
So I put in the 3 now, sir.
So what is the value of the 3? The time, so they want the acceleration at some point in time, some instantaneous point in time, so that we are saying now when your time is 3 seconds, what is the acceleration? So the acceleration we know is 4i minus 12t j. Let's distinguish those carefully. That's not 41. So therefore, this is 4i minus 12, and you put in the 3, and you put the j. Therefore, that is 4i minus what now? 36.
36 j.
All right, so that is what? And if I was to say to you again, Anika, what is my scalar value of my acceleration? What is it, Anika?
4 square.
So this, what do I mean by scalar value? It's a modulus value. The modulus value is the 4 squared 16 plus minus 36 square, whatever that is, and you take the root of all of that. And somebody can give that to me. So the actual value using your Pythagoras theorem is going to be 16 added to the 36 square. And you take the root of all of that. So the root of 1200. $35.78. Is that what you get? You run it off to what? 4 significant figure, 2 decimal place. And what is the unit?
MS.
MS what?
Per second.
All right.
That's an acceleration. That's an acceleration.
Right. So that is what kind of value did I say again, class? That is the value that is just giving you the numerical value, the modulus value of the answer. That's the modulus, that's all we want. We want the final scalar value answer. Scalar quantity. Mean, when I say scalar, I mean it's just a number. So in that case, don't misunderstand. I'm not talking about vector necessarily. Just telling you that is just a the counting number.
No, we know a scalar.
So we say modulus value. So the modulus value of it is that. So we move it from what now? You notice we're moving it from what? From Cartesian to modulus value. Can I get it back from that value? How would I get it back from that? Get it back to Cartesian. That's the big question of the night. So we all know about unit vectors. How would I get it back into Cartesian for 4I minus 36j? If I have that value alone, how would I get it back? And I know two things. I know the modulus value, right? How could I get it back to that? Can I get it back?
You're not clear without you asking.
Oh, it's not clear. Could I, if I only knew that it is 35,
okay,
right? And I have, what else would I need? Let's say I have that, and I said, okay, fine. If I had the unit vector of it, and I have that answer, I could get it back, get back the Cartesian format, 4I minus 3j. In other words, all right, let me tell you what I'm asking. What is the unit vector of that? I could get the unit vector at that point there for that acceleration, or the velocity, or the displacement by just using the fact that I have the modulus value dividing by each one of the quantity, and I get the unit vector there. That's actually what I'm saying to you. You will understand what I'm saying here. What I'm saying here, if I wanted the unit vector of the acceleration, right? It would have been really 4I upon 35 point. So let's say I round it off to 8. Plus, well, minus actually 36 upon 30, 5.6 j. So that would have been the unit vector. When you have the unit vector, you multiply by the modulus, you get back the original answer. That's actually what I'm saying. So whenever you have the Cartesian form of an expression and you find the modulus, you can get what we call the unit vector. What the unit vector does, you remember what was unit vector again from a class? We start talking about unit vector. Anybody want to tell us what is a unit vector?
The points, them, sir.
Huh?
The points.
The points, the unit vector. What we say is a unit vector, first of all. What will you describe a unit vector? What do we say about unit vector? It's a vector. What do we say about it? What's its value?
It have some. Oh, you mean when you mean like one or something like that?
Yes, that's what we're saying. We're saying a unit vector is always one, eh? And what does a unit vector have? Unit vector have what? Magnitude and have direction.
Direction.
So it plots the direction. The fact that it's a vector, it has two things. It has magnitude and direction. Right? So what we're saying there, if you divide the modulus value into the original Cartesian, it gives you a unit vector. That unit vector help you to know the direction of that vector at all times. And you can use it to do intricate calculations. All right, so that is you. So in other words, I'm saying you could find the unit vector. I could ask for the unit vector in one of these quantities. All right, I could say the unit vector of the displacement expression after finding that the value is so after I tell you what to substitute inside here. So let's say for the displacement, suppose I said to you what is the displacement of the particle between, oh, you know, so this answer don't finish. It said the displacement of the particle between these, you know, we need to subtract both of them. All right, I'm running along. So when we find these answers here, V1 and V2, I wrote them, but I just didn't do it. It is actually saying here that we are supposed to find, so it's going to be R2 minus R1. So you're going to group the terms them again. All right, just so you can hear. So it is R2 minus R1. Hang on a second, please. Let me mute a little bit so that I don't.
So I'm going to that question from stop coming down, you know, but it's kind of confusing if you don't understand it. The way it work out.
Come again for me now, sir. That you're saying, sir. I just run that dog around. Come on. So it is all right. So all we need to group the i's together and the j together. So the answer here would have been it was a 6i, and that will be what now? 22i. Am I correct there? And the other one would have been what now? Minus 9. Is that 9 or 8? 8j. Correct? Different. So you'd have group all the what? I together, group all the j together, and had them. So that one will give you 22. One is minus there, so it would have give you what? 8. 8 and 3. Am I correct? 8, 9, 10, 11, right? So it's 8. So it's minus 8j, 22i, and that would have been your. So I can't remember now, it says displacement of the particle between. The word between was there. So you mustn't just find them at I1, 2. You want to know the value between. So you must get the distance between there. All right. Try and read the question properly. I'm running along quickly without reading that aspect of it. All right. So
yeah, that's what I'm saying. What be more structured, sir. There's so much in it to take away. I feel like it too jumbo, you know.
oh yeah, you're right. You're right. All right. So you want us to do it over again?
I can't speak for everybody. I wouldn't mind, but I can't speak for
All right.
everybody inconvenience.
All right, let me just copy.
But you have to put the question somewhere and then structurally go down. Like
Hold on. Let me just copy. Let me get back the question paper, because I hope I didn't let me get the question. All right, I'm gonna have to delete.
But this is a full exam question, right?
Yes, man. Let me see if I can. Where did I get this from without trying to get there is a different eraser. Select objects. All right. Cut. All right. More like it. Fully gone at all. All right. So there is well the question, as you say, a lot to take away. All right. So we did so it's the last part alone I'm going to do over. Let me just clear the last parts and see if I can copy it and carry it clearly somewhere. Again. Come again. All right. So the last part. All right. Now let's see if we
I
can.
mean the last part. What I got?
I'm doing the last part. You wanted the first part. You missed that part too. Because you came in late. Where are you?
Sir, run back the ball game, man. Yeah,
You having lunch, man? You having lunch or dinner while we were here working
sir,
assiduously?
when me come in at one person, me see with them. I know about no we no.
Oh, so everybody drop off. I know, so you're wrong, man.
Okay, me and you and Anisha.
Okay. All right. And Wanisha was here. So you know you talk for yourself.
Yeah.
All right. All right. So all right. So we'll see if we can be a little bit more systematic.
Yeah.
You want us to be a little bit more systematic.
Absolutely. Yeah,
All
absolutely.
right. So we are saying for the first part, C, right? You
They said start?
yes, man. We just doing this part here now. I got doing the other part. You go read up what is precision and
Oh, so simple
accuracy.
something then. Oh,
Yeah,
those
man.
are
You
just
can read up.
definitions.
Yes, man. So it's V1 equals to minus 5I plus 7J, right? And V2 equals to 2I. You know I don't like doing over question.
Why?
You know why I don't like doing over? I'm boring. I prefer find a new question and do, for your clarity, Maybe that's what I should do. You know something? Let's find
So
a
you
different
don't
question.
start the thing already. Go on, roll now.
Come on. Let's find. All right. I just work in this first part here. So the other part I work at already. I'll structure the next one that I'm doing. That's too boring. You're boring me now.
All right.
All right. So all I'm
All
gonna
right.
do, you add this one and add this part here, right? All you need to do is group the terms. So to get V1 plus V2, my brain don't work like you in a boss. You have to get something challenging. So it is 5I plus 2J. So you group all the i's together. The next one you have 7J minus 3J. All right. And simply just group them and work them out. I to I, J to J. And this one is minus 3I. And this is 4J. Right? The other one, we say that you are to determine the direction. If you have the vector, then you can determine the direction. So it goes 3 that direction, and it goes 4 this direction. Right? Because it is minus, it goes in the opposite side. Remember your 0 is from here. Right? Going to the left. And therefore the resultant would have been that. Right? And then your angle, that direction angle will be there. So because as a Pythagoras, it's a 4, 5, 3 triangle. Right? And to get the angle, we say tan is equals to the opposite upon the adjacent side. So the angle point to that side, which is opposite, divided by the adjacent. And the angle here was 53 something. Whatever the answer was, 53 something. 53 must be 0.6. I think that was the answer. All right, so that is what we did. Now I look at different question. I am bored right there. So let's look at different question. Let's look something different. All right, let's go to a different past paper. So that was 2014. Let me see if anything is on 2017. What do I have here? Part of 2017? No, not 14. All right. Let's see what is on 2012. Let's see if we have a simple
whole paper them they are present.
No matter yourself. They're relevant. They're very relevant. Don't worry yourself. When you get them and we restructure them, they're like brand new question. Don't worry, I've written several questions. Nothing is on that one. I've not seen any at that time. All right, so we have another beautiful guy here. Oh, we have a marvelous guy here waiting. All right, let us see if we can get this. First, it says define unit vector. You already defined unit vector, so we're just going to grab this part here. And
Sure, one definition, them they're easy.
All right. I'm glad you say it easy. All right, boss. Thank you. All right. So let's go.
Jump in a C, part C.
What's that now?
No, man, I said let's go to C.
Not we look at the question and see what it says. All right. It says state Newton's second law. You know that already. You're supposed to know that and back. All right. and some people get away. One of the first mark, you cannot get 0 from once you write the formula. Which formula is that I'm talking about? For that part, if you write just the formula, you get at least 1 mark already. And then now from the formula, you can explain yourself. Which formula should you write there? For the first part, D.
First part. Acceleration, man. Acceleration.
Come on again.
Sir, dv over dt.
dv upon dt.
Yeah.
No.
A particle moves in the XY plane.
No, man. Which formula should you write right here? Now this?
Part B. Sorry, a part B, I look on.
B, me say no. B,
C,
boy.
You know, easy.
You know that, me say, man. Me say you get 1 mark already. And then you can do the rest. You can do the rest and write about whatever. Change rate and change of momentum and all of that and get the rest of the answer. All right. Let's look at the next part. It says here, let me see if this is an easy one. If it's too difficult, I'll leave it until we are.
Man, sir, one question.
It's a particle move in the XY plane. So we know what is the XY plane, no, so? Not this plane. This is the X and this is the Y plane. All right. What else it says? With a constant acceleration. Right? All right. So it have constant acceleration. And then it says t equal to 0. The particle at t equals 0, the particle is at r. When t is at 0, the displacement is this. Right down here, so is what now? 4I plus 3j. All right. And so when the t equals to 2, t equals to 2 here, so right, the particle has another displacement right out here, so which r is equals to what now? 10I minus 2j. And they say that is a meter. Both of them are in meters. So the unit are them are meters. All right. Them says
displacement, it change direction.
And right. And then, so in other words, at this point, it is this. Right? So it's right. And then it, at some point too, it is somewhere wherever it is in space. Wherever. You know, some point distance. So it has 2 displacement there. It says at t equals 2, the particle. Okay, it says the velocity is and its velocity. And it tells us something about its velocity. And its velocity changed to v. So this part is our velocity. So 5I, 6j. Right. So at this same point here, it has a displacement of a velocity. Not true? Then say, what is the acceleration of the particle? Right? What is the acceleration of the particle? That is the question being asked. Who could tell me how to approach this one? So you have a displacement when your t is equal to 0, right? It is at that position, all right? 4, 2. That is how some displacement out there. All right. So they say they want to find the acceleration of the particle. Anybody have an idea how this can work? So in other words, let's show you. So we're gonna say this is its displacement. So this is displacement, not distant displacement. So therefore, R1 is equal to what? 4I plus 3j. And R2 is equal to what? 5I minus what? No.
6.
10. Sorry, it is what?
No, 10. R2 at 10I.
10. 10I.
10I minus 2J.
Yeah, right.
R3.
And it's velocity, and then give the velocity. And it says the velocity is that at a particular right. So at the right, when it's at 2, you get the velocity. What is the acceleration of the particle? So what is all right? What do we know about velocity and displacement? And the displacement, which is really going to be what? R2 minus R1 upon T. That's all. Now that is equal to your velocity.
Yeah.
That's all. That is really your average velocity, not true?
R2 minus R1 over time.
That's your average velocity. So your average velocity is right there. So right there, so you have a similar what your average velocity is, right? So right here we are saying your 5I minus 6J is equals to what is R1? R1 is 10I minus 2J bracket minus R1. What is R1 now?
4I minus 3I. 3J.
3J, right. All right. And then now the next one is upon the time. Correct?
Yeah.
So when you work out this now, what are we getting here? So we're getting here 5I minus 6J times T equals to this one now going to be what now? 6I minus, this becomes minus 3 minus 5. Agree?
Yeah.
Right. So that's your displacement, right? But the expression, so the time, but the time is so that is, let's see what value we have here. Now, did they give you a time T? They told us something here. When the velocity is, what was the change in the velocity in the time? It was 2.
Hold on, so the minus.
It was from 0, it is 2, no, so. So the time was the time, we got the time. What was the time?
0.
The time wasn't 0. The time was 2. It changed between, where did it start from again? Where is it? Where is it? Where is it? It says time is 0 until the time becomes 2. So the change is actually 2 seconds. So it's 2 seconds here. So this is, all right, pause. Keep this as R. The R1 minus R2. So that is actually your displacement. So your displacement here, all right, even though I work it out there, this is called this R1 for clarity, R2 minus R1. So it's going to be really, which is really up here. This is R2 minus R1, right?
Sir,
So
when we get the minus 5 though.
It's minus 5 here.
6I minus 5J.
Remember they gave it to us? See velocity here? See velocity there? You forget what was the velocity? Velocity is 5I minus 6J. So it's 5I minus 6J. Right?
No,
so that
man.
was it times T.
No, man, up top there, sir.
Where are you talking
Exactly top side what you just wrote, where you got that 6I minus 5J.
This. Oh, I was actually working out the displacement
10I
Cartesian.
minus 4.
Yeah, so it is really R. The displacement is really R2 minus R1. So it will really work out to be equal to 6I minus 5J. When you take away these two.
4I from 10I, 6I.
Yeah.
But then minus 2J plus 3J.
Because you have a minus and multiply the plus here, so that become minus. So therefore you get minus 5. That's all? Correct? Minus and minus of 5. Yeah, so that is it. That's it, right. So here, so if you actually want to work out your, which is the same thing we work out here, the displacement here, when t equals to 2, you can actually put it in here. So you get 5i minus 6j times 2. So this is only what? 10i minus 12j. That's really the value displacement when the time is equals to at t equals 2. Right? So the actual displacement that. But that's not what really asks, you know. I'm just filling out the first part of the question. They actually want the acceleration. Right. So in order to get acceleration, what was the velocity that I gave you? You have the velocity, right?
5 minus 6j.
Right. So the expression that we have. All right. So the expression that I'm having here, let me tell you what I was doing up top here. Let me symbolize it. So we're going to call R2 minus R1. Right. Now, R2 R1, what was the answer again? It was equals to
10i minus 12j.
No, hold on, man. Before you put not put any 2 to it. That's the difference. Right here. R2 minus R1, don't? All right. Your velocity was equals to what? The displacement. Oh, how am I writing it wrong? It's going to be equal to R2 minus R1 upon T. All right. That's the velocity there. So from that expression, I am going to call R2 minus R1 R upon T. So that is the displacement. So from that, I'm going to say my R is equals to T times V. So my V was what again? 5i minus 6j. We actually prove it, you know, by working it out. You realize that though? Times T. So it was actually that. All right. They said to you now, find the velocity of the particle there. What is the so what is the acceleration of the particle? So the acceleration, if we know a velocity, we can find acceleration, don't? So let me approach it this way. See what's it. So your dv upon dt, in order to your velocity upon t would give you acceleration, correct? dv upon t. This is what? V. Let me write the symbol then properly. So that is v equal to 5i. So if you differentiate the velocity, let me check this out. If you differentiate the velocity here, you're getting back this for your acceleration without the t in that instant. What I'm doing is actually forming an expression for the velocity. You realize that they didn't give you an expression here, so I am forming an expression for it. Did you realize that's what I'm doing? Look, I'm saying that your velocity is the displacement upon time. The average displacement upon time is it. So all I'm doing is call R2 minus R1 your R2 minus R1 your displacement. Right? So that is the difference between them. The difference between them actually upon T is actually, when you check it out, it's the same velocity that they tell us is in the problem. Where is it again? See it right here? 5i minus 6. So you subtract these two here, you get this. Because, and they are showing you right here, you when you work it out. So if you work it out over here and put T upon this is your displacement upon T. This is equals to 5i minus 6j. This is actually what you get. Same thing when you put this. So when the time is 1 over here, it becomes the same thing over here. However, there's a t here. The t here, because it's average, the t must multiply this expression. And I said R2 minus R1, we're gonna just call that R. So that is a displacement expression. That gives me this expression here. 5i minus 6j times t. Right? So therefore, if this is your velocity times t Where am I? Hold on. This was actually incorrect right in here. This is actually R. So remember, this is the formula that I'm working with here. Your velocity is equals to R upon T. So therefore, when you cross multiply, your displacement is equal to VT. Let me not get you confused right there. So this now, you know your velocity expression, you know T. So you multiply it, you get 5I minus 6J times T. If you were to differentiate this, what will you get? Sorry. If let's say you are doing differentiation, what will you get? That would go to 1 and you'll only get what? 5I minus 6J.
Yeah, that's it. I'll go in.
You understand me? And you would get that your acceleration. So no, hold on. So this would be, let me write that properly. So this would be your displacement, and this would be 5I minus J times T. So that is your, to get your velocity, you do dr upon dt, you get what now? You get your velocity. So your velocity will be coming to, this is 6, will be coming to 5I minus 6J. All right. Now they want.
Where did D find on the formula again?
Where? Differentiation.
The D in the formula. Oh, okay.
Yeah. So all right. So you have your, so what is the acceleration now? Acceleration is gonna be what? V upon T. So so your velocity is what? 5I minus 6J upon T is the acceleration. All right. So from this now, your acceleration, right? At what time did they say they want your acceleration now? They say what is the acceleration of the particle? At t equals 2, that. All right, so they give you the change in time. So when the change in time now, they tell us something about constant acceleration at first, So the acceleration is constant. Right? Right, so the acceleration is constant. So when you change in 2, if you put 2 here, you know what your acceleration is going to be now? 5I minus 6J. The change, this T is representing what? Is T2 minus T1. Right? Which was what? It was what? 1 was 2 and 1 was what? 0. That was it?
Yeah.
Look back at the problem. Yes, 0 and 2. So the change will be what? 2. So therefore, you put this over 2. Right? So this will be 5 upon 2I minus 6 upon 2J. So your answer is 2.5I minus 3J. That's the acceleration. Now, if you want to get the modulus value of the acceleration, how do you get the modulus value of the acceleration? The actual value. I have to go back to this question. I'm going to go back to this question for clarity next class. I'm going to review it. So the square. Yeah, so you do the Pythagoras and you get it. So this would be 2.5 square plus 3 square and take the root of that. And you'll get the actual acceleration at that point. Because remember, they said that this is a velocity, The velocity down here at this displacement, you could assume that the velocity is 0 at this point, because this is the expression, this is where you're at. It's not accelerating at this point, but this is where it leaves from, right? They never tell anything about velocity. Velocity considered as 0 at this point. So the difference between velocity 1 and velocity 2, so the velocity 1 is 0. Velocity 2 would be 5I minus 6J, which we clearly saw when you subtract the displacements, right? When you subtract the displacement and put it over T, you actually realize that the displacement upon the time T would give you the velocity up there, right? I'm gonna review this question. Yeah,
it's a good idea. It's a couple of these questions on the topic.
I'm gonna review this question and look back at it. All right, and then it asks you, what is the velocity of a particle as a function of T? Now, what they're actually asking you to do here is to formulate the same expression that I was telling you to formulate. You actually have to formulate the expression that I have there, right? They actually just telling you to formulate the expression. So this is a expression with T for the displacement. And when you differentiate that, you would have got the velocity, which is this. And they say you must do it in T. Hold on. They say do it as a function of T. So we actually show that. So if you put the displacement upon T, then that is a function of T. Or when you have R, the 6.12 over T, that is the expression for the velocity, right? Upon the, where do I have it here? Trying to show you this part here. So this is the displacement, right? And from this you can show the velocity. So displacement upon T is a function, right? But I don't too like how the phrase, the question, it can be misleading too. And then they ask you about the position vector function of T. I'm gonna review this question, guys. What are they asking for? The same thing down here, so. But I don't think you can manage this type of calculus yet. So I'll defer it a little bit. I'm gonna go through it, but I'll defer. Let me, if anything, I probably could prepare it and go through it properly for this section here. This is because you haven't got to, you don't know to differentiate trigs yet, right? You haven't done anything like those.
Not yet.
Right, so I can't, so if I, all right, I'm gonna look back through this question and review it. Somehow it's the first time I'm actually working this question. Didn't even see this one before. Oh, okay. I need to check on it. Oh, it's 2017. No, it's not the first time. I'm the one who actually wrote this question. Trying to remember that part of it. All right, this is, so we have done that. All right. Yeah. All right, I'll review this question. I will go through it in details again because they want the position vector as a function of T, right? So you know, so they want the distance. So first I want the acceleration, right? So acceleration, you see this question here? Let me tell you, this question here, what they really want, two things. Let me tell you, you see this question is actually working the problem the other way around. So you can look at it. If you have, to get acceleration is velocity, is what? Velocity upon time, that's all, right? Correct? Is your change in the velocity upon T. Now you have your velocity, which was what? What was the velocity? 5I minus 6J, right? Per unit your T. So right here, so you get an expression for your acceleration. The same thing, they say the function, they say, what is the velocity as a part of the function of T? So this now, your velocity is really, they're saying to you that if you have this, right, you can get a function for your velocity. I'm gonna read the question through to figure out how to display it properly because it's a little bit misleading in terms of what they're asking here.
Yes,
right?
sir.
Yeah,
So
yeah.
tomorrow, I know tomorrow we have you.
No, it is, you have me on Thursday. All right, this question, I'll review it so that I can give you some clarity on what they really ask, you know, and how for you to state it properly, right? This part now, I'm gonna defer it until I probably, maybe when we're reviewing, by when you think you'll be doing trigs, how far you reach with your calculus? If not, I may have to teach it. How far you reach with your
So
the
I'm
trig
never going to
function?
go last maths class.
We do differentiation.
No, you do differentiation of trigs yet? That's what I'm asking you. Because this include differentiation of your trigs. You see
No,
this
we don't
part
do
here,
that.
you see the
I'm not
first part
sure
here.
it's gonna be in next class.
Oh, okay. All right. You see the first part of this question. It is all about formulating expression. It's not so much any differentiation, guys. It's more about formulating the expression. May have a little, right? And then this part knows where the differentiation, the calculus comes in. All right. So this part is just using the formula to come up with your correct expression. All right. All right. So we review that part. All right. Before I go though, we have at least 5 minutes. Please put your name in the chat. Let's look back on the slide. So a couple things to point out. All right. A couple things to point out. I don't think we have gone through this part of the slide. Something that we call product of a vector. Now there's something. Who is this out here? All along. Osh, didn't realize that that person is hanging there to come in. All right. Product of a vector. There are two different ways in which we can usually define the multiplication of two vectors. All right. Now, this is very important in physics and in statics, and maybe to some extent you may come across in maths. Maybe not this maths group that your class that you're doing now, but somewhere along the line. So we have two things that we have dot product and we have scalar product. Huh? They are very important in helping you to figure out problem in vectors. So you have two ways, and one is scalar product, one is dot product. Let's explain quickly what is. So each of a length A times B. So when you have two vectors, right, and there's an angle, so that when they meet, from once they meet at a point, the angle between them, right, is what they say the each length of the vector, which is A modulus B in this case, is a number, and the cos theta, that means the angle between them, is number. So A times B, all right, A dot B is not a vector, but a number or scale. What do I mean by A dot B is not a vector? It means that it's a product of the vector. It's the actual what you call now the scalar quantity of the vector, right? So they said A dot B is not a vector, but a number or scalar quantity. That's actually telling you. So if you multiply two vectors, in this case, what you're doing is multiplying vectors. That's why they call it product. So not only do we add vectors, we multiply vectors. So for example, let me give you an example. Let me give you an example. You have let's say you have a vector 3i plus 4j times a 2i plus 3j. All right. So you have A. Let's suppose A is the 3i 4j, and this is now 2i plus 3j. Now, when the product, the A dot B is the product of the vector. The product of the vector means that it's going to be 3i times 2i. 3i times 2i is 6i squared. All right? Plus 4 times j. Now, j times j is 1. See that down there? So it's 4 times 3 is what? 12. So it's 12i squared. You know what that means? I squared is 1, j squared is 1. So this gives you what? 18. So that you get a numerical value. That's all it is saying right there. And so in order to work this problem now to get the angle, the cos theta, it is saying to you is that the 18 will divide the modulus of each one of the vector. What would be the modulus of the first one? The modulus of the first one would be 5 times, what's the modulus of the second one? It will be 4 plus 9. It will be root 13, or so. Correct? So whatever than that would give you, from that you can find the cos inverse of that angle. 18 divided by the product of that. And it will give you this angle right here. So that is what we call, that is scalar product. Yeah, in other words, you have scalar and dot product, right? So that is more explaining to you the dot product aspect of it. So there are two ways to look at it, right? So you have the dot product and you have the scalar product, right? Scalar product and dot product are different in that for the scalar product, when you come to these, they are 0. So if you go I times j is 0 and so forth. So you have to take note of those. I'm going to find a problem with scalar product. This is more dot product. So you have two of them. You have scalar product and you have dot product. So it's two of them you have, right? And this explains to you special cases, right? So you have to know how to navigate when you're doing using scalar product versus dot product. The rule that works for scalar product is different versus dot product. So the one that I just worked a while ago is the dot product one. This one you probably see a lot in maths. The scalar product one is different. It's not an easy multiplication. It doesn't necessarily mean that if you multiply, so in other words, this one will work out to be 18. The other one, so it means there, so when you go I times, so if you go 3 times this, it give you 6. But when you go 3 times 3i times this part here, so it's not going to give you 0 like down here. It will mean that you have to find out what I times j. I times j can have a value for scalar product, and it gets a little bit more complicated. So I'll do this one in statics. I'll show you this one. I don't think I necessarily need to show it in this one, but this is a dot product. What I show you here, this is dot product. The scalar product, you will meet that in statics, right? I'm not gonna bother to. You don't need to know it now. It's not relevant now. You're not gonna get it in the syllabus. So the dot product is more like what you will see in the syllabus, right? So this one, even though I have it there, I'll explain it in statics course. You'll get it full blast. So this one is explaining more dot product. So it's two of them. So there are two different ways in which we can use to define the multiplication of two vectors. Scalar product and dot product, but this one is more talking about the dot product aspect of it. So there's product of a vector and how they are used to explain. All right. We had worked that problem already, so we're not gonna go through that. That is fine. Let's see a modulus. And it is pretty much showing how to use the trig that we can go to next class. All right. Next class, we just go through that little part there, and we work back the finish work of that problem. I probably have to just introduce you guys to the trig differentiation. You know, will help to help you when you go to your math class. It probably does help. All right. So that is gonna be it. Please drop your name in the chat for me. Let me see if everybody have registered in the chat. Okay. I'm not seeing. Oh, Kenrick is there. Okay. All right, cool. All right. What time do we have here now? What time is it now, guys? I'm trying to.
9:26.
9:26. All right. That's here where it is, you know. Question. You should you can start the question on the paper. You have at least another week and a half to start it. there's a question there. Hold on.
Sir, which paper that, sir?
Hold on, I'm looking. Hold on, I'm trying to exit this thing here, not allowing me. Discard. So in Moodle, where's the Moodle site here now? Did I close it? I hope not. There is a question. Moodle site here. Where's the Moodle site? Moodle. Where is it? Where is it? Come on. It's worksheet 2. Yes, man. Here it is. Right here. Hold on. That's not what I want. Well, I'm trying to find the worksheet. Hold on. Let me go again. Let me show you what is the question. Right. So this is it. I mean, the first part is not too much. It says state them. You state all the laws. All right. And yeah, it's straightforward. Yeah. So this is the assignment. Right. This is the assignment. Right. Everybody should be able to do this and submit it. Now, what timeline do I give you to submit this? What timeline do I give you to submit? I don't think you need a lot of time for this. All right. Let me see the time you need to. All right, so that worksheet 1. No, guys, worksheet 1, only 2 persons do worksheet 1, you know. We're not going to allow that. Worksheet 1. Ignore the participant thing here. I'm just trying to find it.
Sir, when you mark it, can you give me some feedback, please?
Yes, I will give you feedback. The worksheet 2, I'm trying to edit. Let me just edit. Edit settings. Save that. All right. So worksheet 2. What time is it now? We're gonna set some time. We're gonna tell you when to submit it. Enabling. So we're gonna enable. All right. We're gonna enable time period. Today is the what? The 11th or the 10th? The 10th. So I'm gonna give you by the 20th, the latest the 20th, or before that. I'm gonna give you about the 18th. The 18th to submit. Well, hold on. So today is the 10th. Allow submission from here, or let me do it here, and it's due on the 18th of the month. Right. So I'm putting my due date. Okay. So I'm going to remind you in October on which day now. All right. So enable that. Do I have a cutoff date? Yes, I'm going to put a cutoff date. If I don't put a cutoff date, I won't get this assignment. I know the class already. No, most students. So your cutoff date is going to be the 20th. So anybody who submit after that means they don't really want this grade. 22. So that's the cutoff point. And that's as lenient as I can be. That means you're going to have the work, you're not going to be able to complete anything if you're not going to push yourself to have a so the 20th. All right, and that is fair. All right. All right, so that's that. So that's a cutoff date. Right. Is there something right now? I mean, oh, what is this? Remind me. Oh, oh, okay. All right. Correct. All right. So that's it's. So you know when your due date is. It's taking so long. It's so long too.
All right, sir. Good night.
All right. Good night. Good night. I'm just trying to set up the thing is. Moodle site is taking a long time to actually do what it needs to do. Okay, it's done. All right, it's done. It's a done deal. Ignore this participant thing here. That's coming from a setup. I need to ask the Pinnock about that. Why is it that I have these underneath here? I hope that don't cause a problem. I'm gonna ask them why I'm having these here. I really don't know how to remove them. I don't want to delete anything and any grades get deleted. That happened to me once. I really don't want to do that. See it? So my students are grade about to be deleted. I don't understand what is that. All right. I don't teach a course now, so I don't understand what is going on. All right. So guys, have a good night. That's it.